Welcome to this complete tutorial on bar bending schedule, commonly known as BBS, one of the most important topics in civil engineering and construction management. In this lesson, we will understand what a bar bending schedule is, why it is used in construction projects, how to calculate reinforcement quantities, and step-by-step procedures for edge-to-edge execution, how to prepare a BBS sheet, and how engineers use it on construction sites. By the end of this tutorial, you will be able to create a basic beams, columns, slabs, and footings with confidence. The bar bending schedule, or BBS, is an essential list that specifies the exact size, shape, number, and weight of the steel rebar. A bar bending schedule is crucial in steel fabrication. It bridges the cutting, bending, and placement of reinforcement bars. This ensures precision before the concrete is poured. A properly prepared bar bending schedule improves construction quality, reduces material wastage, saves time, and provides accurate quantity estimation. A BBS serves as a bridge between. Let us understand why BBS is important. First, it helps in accurate steel quantity estimation. Second, it minimizes wastage during cutting and bending operations. Third, it improves project planning and inventory management. Fourth, it helps contractors estimate project costs more accurately. Because of these benefits, BBS is used in residential buildings, commercial complexes, bridges, dams, and all reinforced concrete structures. Before preparing a BBS, we need to understand some important terms. Diameter of bar. The thickness of the reinforcement bar, usually expressed in millimeters such as 8 millimeters. For 8, 10, 12, 16, 20, 25 and 32 millimeter rebars, the cutting length is the total length after including bends, hooks and anchorage lengths. Let's discuss concrete reinforcement. The development length is needed to transfer stresses safely, while cover protects the steel from corrosion. Both are critical for structural safety. Today we will discuss shape code and hook length. The shape code is a standard code for engineering. Hook length provides proper anchorage. This is vital for structural safety. To prepare a BBS, engineers first study structural drawings. Important information obtained includes bar diameter and spacing between reinforcement bars. Number of bars, concrete cover, beam dimensions, column dimensions, slab details shown in structural drawings become the foundation for preparing an accurate bar bending schedule. To calculate steel quantities, we use the standard formula d squared divided by 162, where d represents the diameter of the reinforcement bar in millimeters. Let's explain construction rebar diameter details. For 8 and 10 millimeters, here are 12 and 16, finally 20 and 25. Now let us learn how to calculate cutting length. The cutting length depends on straight portions, bends, hooks and development lengths. For a straight bar, cutting length equals actual length. For bars with bends, additional lengths are added or deducted. Typical deductions include several angles. We have the 45° and 90° deductions, also the 135° 80° hook deductions. These are essential for accurate steel cutting. Let us take an example of a reinforced concrete beam. Suppose that this beam has a length equal to 5 meters, width equal to 300 milli and a depth equal to 500 millimeters. Let's use these details for our calculation. Main reinforcement consists of 4 bars of 16 millimeter diameter. Stirrups are 8 millimeter diameter at 150 millimeter spacing. This ensures structural integrity. Let's calculate steel bars. Step 1. Find the cutting length of main bars. Step 2. Determine the number of bars. Find the cutting length of stirrups. That's it. Step 4. Calculate total steel quantity. Step 5. Multiply total length by unit weight to obtain the steel weight in kilograms. For a column, reinforcement generally consists longitudinal bars with lateral ties which wrap around them. A BBS includes the bar mark and diameter as well as the total number of bars. We need to calculate the length of each bar, the total length, unit weight and total weight. Special attention should be given to lap lengths and development lengths in column reinforcement calculations. In slab reinforcement, bars are arranged in two directions: main reinforcement, distribution reinforcement. A construction site is a build structures using safety gear and heavy materials. Slab BBS is particularly important because slabs contain a large number of finding the number of bar plus 1. After finding the number of bars, calculate the cutting length and total steel quantity. A typical bar bending schedule contains the following columns: bar mark, member name, bar shape, number of bars, cutting length, total length, unit weight and total weight. While preparing a BBS, avoid these mistakes. Never ignore concrete cover or use incorrect bend deductions. Watch out for wrong bar counts and forgetting lap lengths. Always double check structural drawings and unit weights. Modern construction projects often use software tools for BBS preparation. Popular tools include Microsoft Excel, AutoCAD, and Revit and Tekla software. Thank you for watching. If you found this tutorial helpful, continue practicing with real structural drawings and BBS examples to strengthen your understanding and professional skills.